Did you even know about this function? Hello and welcome to another lesson by Positive Increment. Today we'll dive into the proof of the connection between the Liouville function and the Zeta function. We will start by defining the Liouville function. Given a natural number n, the Liouville function of n is 1 if n equals 1, while if n is the product of k primes with exponents a1, a2 to ak, then the Liouville function of n is minus 1 to the power of a1 plus a2 plus till ak. Notice that by definition this function is completely multiplicative, that is to say, lambda of p times q is equal to lambda of p times lambda of q for every natural number p and q. This clearly implies that lambda of n is equal to the product of lambda applied to each of its prime factors. We will use this last property immediately to simplify the series. Notice that, by the fundamental theorem of arithmetic, summing over all natural numbers is exactly like summing over all possible products of primes. That is to say that the series from 1 to infinity can be substituted with the product over all primes of the sum over all possible exponents. This type of reasoning is identical to the one used in demonstrating Euler's product formula. If it's not clear, I suggest you check out that video. Now, using the definition of the Liouville function, let's isolate this series. By hypothesis, the real part of s is strictly greater than 1, and therefore the absolute value of 1 over p to the power of s is strictly smaller than 1. With these properties, this is a converging alternating series with this result. Let's put this back into the equation. Notice that with some simple algebra, this result can be written as 1 minus 1 over p to the power of s over 1 minus 1 over p to the power of 2s, which can also be written as. In this form, we recognize the Zeta function thanks to Euler's product formula, which allows us to conclude. Thank you for watching. I hope to have addressed any questions regarding this formula. If you enjoy this kind of content, please subscribe to the channel. If you have doubts about another formula, you should browse to our channel or leave a request down below. Remember to study hard, and I will see you in the next lesson.